So this evening we are going to be joined by an awesome young man by the name of Steve Hart. He is a CISSP, CSSLP, CCSP, and any other CS abbreviation that you can probably think of. This guy is it. He definitely is one of those guys over there at SAS. So if you guys are definitely cool with it, give him a round of applause, welcome him, and if you have questions, go ahead and post them, and we'll try to answer them to the best of our ability. And Steve, go ahead and take it away, my friend.
All right, thank you very much. All right, thanks everybody for sticking with this and coming to a late session here at 5 o'clock. Is probably, I know it's been a long day, a lot of interesting sessions going on throughout the day, and just happy to be here and be presenting to you today. So yes, my presentation today is on secure SDLC lessons learned. I am the head of product security in SAS Institute. I work in research and development and essentially run a software security assurance program in research and development to ensure we're building security assurances into our products and solutions that come out of research and development at SAS Institute. So let's move on to the next slide here. So the agenda, we're going to talk about software security assurance. We're going to talk about security practices within the SDLC. We're going to talk about security scanning, penetration testing, red teaming, and some lessons learned along the way. All right, so first a little bit about SAS, some company facts. So we have customers in 147 countries. So yes, we are a very global company. All over the world, we have clients that we work with. And customer sites, we're in 83,000 different businesses, governments, and university sites across the world. We are also, our customers include 92 of the top 10 companies in the Fortune Global 1000. As for employees, we have about 14,000 employees worldwide. A large number of them work in the United States, and specifically right here in Cary, North Carolina, at our headquarters. But we also have presences and sites across the globe here as well. So a little bit about our products and solutions. We are, 40 plus years of analytics innovation. We have advanced analytics solutions, AI solutions, business intelligence, the SAS cloud, as well as others listed here. We also have solutions in fraud and security intelligence, as well as IoT analytics and risk management solutions and the others listed here as well. So just kind of wanted to give you a little idea of what we do and what some of our products and solutions look like. So going back about 5 years or so when I first joined SAS, one of the things that we noticed at that point was an increase in the tech support security tracks. They were trending up. Again, SAS has been around for over 40 years. We know security. We have it built into our software. We've worked for many years with our customers on security issues. But this trend was a bit new in the 2015, 2016 timeframe, where just the sheer number of issues that were coming up, caught us a little bit by surprise there that they were increasing over time. Month after month, we just saw more tracks coming in. And there were really multiple drivers for this. So as you all know, I'm sure you're well aware, there were many high-profile, publicly documented zero-day vulnerabilities and data breaches in the news. None of them specifically targeted SAS or SAS software, but given that those high-profile zero-day showing up in the news made the entire industry really focus a lot more on this topic. At the same time, there are stronger industry standards and regulations raising the bar for security, which is a good thing, and they continue to raise the bar now. So we saw our customers becoming much more aware around security, and not just from a network point of view, but from a software point of view. We're a software company. We sell solutions and products that run within their data centers or within their cloud environments. So they were focusing now on our software as a potential area of attack surface. And our especially risk-averse customers were improving their own organization's security posture, which was, building up their own capabilities. They were building up security teams. They were building up, scanning capabilities. One of the things we noticed in this time frame in 2015, 2016, just lots and lots of scans and lots of raw results coming in through tech support. So not necessarily even real security vulnerabilities at this point, a lot of scan data just coming in. And that was a learning experience of just trying to figure out how to read this scan data coming from, as I'm sure you're well aware, there are tons of different tools out there. There are many different vendors out there providing all kinds of solutions that will help you with your security posture and help you identify vulnerabilities and concerns in your environment. A lot of that data is raw when it's produced by the scan. And at this time frame in 2015, 2016, we were getting a lot of this raw data sent in right through our tech support system that our customers were expecting us to kind of distill for them and help them figure out what it all meant, if there were really concerns in the software or not. So moving on from that, the question comes, all right, well, how do we get ahead of this? How do you deal with this from a software security point of view? And the answer to that, our proposed answer to that, is to build a software security assurance program. And many of you may be familiar with the OWASP. One of the great projects they have out there is the SAM, the Security Assurance Maturity Model. This is a great framework for how to build security practices within your software development lifecycle. But what is software security assurance? And what I propose is it's really a methodology for building software that protects the data and the resources it contains and controls. The OWASP SAM is a great framework to show you how to do software security assurance, to show you what are the practices that are used across the industry by other vendors, by other organizations and institutions to ensure they're building secure products. Another great thing about the SAM is it has good alignment with other really good industry standards, guidelines, and frameworks, such as the NIST SP 800 series for computer security. ISO documents. The ISO standards are international standards for security. 27034 is specific to applications and software security. It also has alignment with the Microsoft Security Development Lifecycle. So it's been very well referenced across the industry as a good framework. I'll also note the SAM that I'm pointing out here, version 1, which is what we used back at the start of 2015 of building out the security assurance program, is really about 11, 12 years old. It's been updated throughout the years, and some revisions have been made, but really in January 2020, those 12 practices that were kind of, they were good. It was a good system for building security into your SDLC. Those 12 practices have now turned into 45 different boxes. So again, the bar's been raised. There's a lot more to consider. There's a lot more guidance in here. Again, this is a great resource provided by OWASP. Definitely recommend everybody take a look at this if you haven't looked at it already. And I would say one of the major, compelling things that draws to me about the differences with the SAM version 2, it's kind of like this middle part of the picture there. In the implementation phase, things like secure build, secure deployment, and even defect management. There's a lot more guidance and new sections around this in SAM version 2 that are very important to look at. And even in the verification phase, the requirements-driven testing and the security testing. Security testing was in SAM version 1, but in version 2, they really do more of a breakout between the scalable baseline there and that deep understanding box. So a lot of really great guidance there, very good to look at to help you build out your own program. All right, so moving forward, so moving to initial phases of how do you do this? How do you come in and build a new secure software development lifecycle program or security assurance program within a research and development organization? One of the first things really you have to do is you have to transform from being reactive to proactive. So as I showed in that chart where we were trending up there with new, numerous tracks coming in through tech support, you really have to build out a framework for how you're going to handle that. And a great resource there is actually the PCERT services framework from the first organization. So really the first step is incident response. We've had a tech support system for 40 years. we didn't necessarily have an incident response system within that tech support system. So that was kind of one of the first things, foundational things that had to be established. How do we handle these issues? How do they get triaged? What is the process for that? There's certain experts that are trained and educated on how to handle that. The P-Cert Services Framework is a great resource that explains to you end to end how do you handle that. And there's contributions from industry leaders into that framework that really validate that and provide it as a extremely good guidance for you. The next phase is, okay, once we have an incident response process to deal with the influx of tech support tracks coming in from customers, how do we be more proactive within the actual development of the software to get ahead of this stuff, right? Obviously, you don't want to just continue to build software that's going to be released to customers and then generate a bunch of concerns from your customers and then have to deal with that all again with your incident response process. The goal is really to build software as best you can and perform all of the security practices within the SDLC so that when you're producing a product, you're not generating tons of tracks coming back into the tech support system, right? And that's really what software security assurance is about and what the OSSAM really digs more into. So my next recommendation here is really just to organize around industry standards, frameworks, best practices, and guidelines. So I mentioned the first organization forum for incident response and security teams. Great resource there. Definitely would recommend that for incident response processes and just P-Cert in general. CWE's common weakness enumeration. It's important to be able to categorize and classify the different types of issues that come in through tech support and the different types of issues that you're identifying internally within your organization. It's important for a number of reasons. As you're communicating within your organization to teams, to leadership, to developers and engineers, just saying we have a bunch of security problems is kind of vague, right? It's not, it doesn't really clearly explain what the problems are. CWE is a great resource because you can classify different types of issues, right? Maybe we have injection problems. Maybe cross-site scripting is a problem. Maybe we have problems with using third-party components with known vulnerabilities. That's kind of what CWE helps you with. If you adopt CWE and you start to classify the issues that are coming in and mark them for what type of weakness has actually been reported, either internally or from our customers, that will then later help you on when you're trying to build out metrics. When you're trying to figure out, well, do we have certain areas where we are just systemically weak, or we just have repeat issues over and over again? Having that data associated with each of the issues that get reported and identified against your products and your software is going to help you later on as you try to get more focused on which areas do you really need to up your game on. CVE, another very important aspect of all this. If you're using a lot of open source, if you're using a lot of third-party components, well, they're very likely tracked in the National Vulnerability Database with CVEs and CVE numbers. So that's another good way to track issues. Our customers typically come in, lots of times they just come in with a CVE number, right? And they have a generic question. Maybe they have a threat feed that has told them a new CVE has been published in the NVD, and they just want to know, what is the status? Are we affected by that? Are we not affected by that? Is there a concern? Is there a patch? Those are the type of questions we come to get. CVE is definitely a good way to keep yourself organized and to track this as you work through issues reported against your software. CVSS, so when we're scoring the vulnerabilities, so we've categorized them now with CWE. We use CVE to figure out, okay, are any of these associated with a third-party component or an open source project? CVSS now is about, all right, well, what is the severity of the issue? Is it a critical? Is it a high, medium, low? Is it just informational? That's going to help with the prioritization of the work and determining, which items need to be resolved first, and which buckets, to put each of these things in. Again, I mentioned OWASP again. OWASP is probably the leader in web application security guidance. There are tons of great resources out there to use, including not just the SAM, but they have many tools and other projects that are helpful. And then NIST, organizing around NIST and FIPS for a lot of their cryptographic standards is very helpful. And again, the 800 series, SP 800 series for computer security. All right, so now that we've gotten through the industry standards, the guidance, the frameworks, the best practices are out there. Now it's like, okay, how do we now embed this into the software development lifecycle? How do we get these practices within the SDLC? And what I'm kind of showing here is a release cycle per se. And this could be, it could be the traditional old waterfall of 12 months, 9 months, 6 months, maybe every quarter, or it could be monthly releases. Everybody's moving to monthly, continuous delivery now. But what you need to really do and focus on is how do you embed each of these practices within the overall development process within the organization. And starting with threat modeling. So threat modeling is one of the very first activities to focus on when you're doing design, when you're coming up with new systems and you're trying to build out and figure out how to architect the system. Perform a threat model and find out what are the risks, where are the weaknesses within that architecture. Security scanning. Security scanning can be very helpful throughout the entire SDLC, starting with software composition analysis. There's plenty of tools out there that will scan your packages and identify known vulnerabilities associated with maybe any third-party content or open source projects you have in your software. So that's back to the CVEs. Static application security testing. There's lots of tools that you can use to just point to your Git repositories or your code, whatever your code repository system happens to be. We'll scan your code and give you information about any vulnerabilities that's identified in your code. And then dynamic application security testing. This is good once you're in the testing phase. Once you've deployed the software, you have test systems up, the quality assurance team is banging away at it. Throw some DAS tools at it and maybe do some fuzzing on it. See what kind of results you get back there. They'll try to inject malicious payloads. They'll try to, do some strange things with the input parameters. See what kind of issues you get out of that. Those all will help you, inform you about the security assurances or lack of security assurances within your software. And then penetration testing. This typically does happen in the latter phases of software development, but there's really no reason it has to. It should happen earlier on if possible. Penetration testing goes deeper than the scans. Penetration testing is actually trying to do manual exploitation of the software. As you're rolling out these processes and these practices and tools within the SDLC, it's important to roll out also guidance, right? Engineers, developers may not be familiar with any of this. They're probably, many of them, maybe this will be the first time they've heard of any of these terms. It's important not to just roll out a tool and say, hey, go run the tool. Really need to have guidance that goes along with that to help people do the right things. And again, I point back to the OS projects. So the OS projects not only have tools that are free, there's plenty of commercial tools out there you can buy as well. They do have some free tools for you in OS, but they also have tons of guidance to just explain to you what are the different types of issues. You can start with the top 10. The top 10 is top 10 security issues that are identified in software projects across the industry. That's a great starting point. But then they have additional guides for testing guides, secure coding, other considerations, verification. There's just a ton of resources out in the OWASP that I recommend looking at. The next thing really is security champions. So if you have a large research and development organization like I do, you're not going to be able to just as a small security team run around and help everybody all day long with doing all these tasks against their specific software projects. You really need to build a security champions network. And these are really your representatives in each of the individual development teams. Commonly, my experience, development teams could be, they could be 5 people, 10 people, 15, 20 people. Maybe you have larger groups than that. But in each of those groups, you need somebody who's mindful of security, of all these practices that need to be embedded within the software development process, and who's really your eyes and ears in that group, and that's your security champions. And really building a relationship and supporting your security champions will help you drive that into each of the individual development teams and the testing teams as well. You want quality assurance to be buying into this as well, and to be performing not just the regular functional testing, but negative testing, right? We know how the software is supposed to work. We know what the regular use cases are. Now we need to build out the abuse cases. How can a malicious actor come in and do something different? And what can they do if they try to do something different, or if they try to do something malicious? And then really it's about, after you've got that established, it's about shifting all this to the left. So don't wait till the latter phases of the SDLC to perform any of this. If you're waiting to the end, it's often going to be too late. If you identify a bunch of security issues in the last couple weeks of the release or in the last sprint, you're probably not going to have enough time to fix them, because a lot of times these issues can be gnarly. They can require, rewriting significant amounts of code. They could require upgrading your third-party dependencies. And as we know, with open source projects, they change their APIs all the time. So if you have to upgrade to a major release of a new open source project and they've just changed all their APIs, now that means your developers have to recode to those new APIs. So running any of this late in the cycle is really going to impede your ability to get any of this fixed before releasing the software, or it's going to push out the schedule and make you not release the software. So it's really important to run each of these practices as early as possible and as often as possible. It just needs to become a regular thing that your developers do as they're building software products. So the next thing I want to really talk about is, let's get a little bit more into the differences between security scanning, penetration testing, and red teaming. Talked a little bit about this in the previous slides, but let's start with security scanning. So as I noted in the OWASP SAM version 2, they really break out the differences between a security baseline and more of a deep understanding. And if you read into the sections of the OWASP SAM version 2, it's really the difference between this top layer here that says security scanning and this middle layer that says penetration testing. Vendors, lots of vendors out there with security tools, they have great tools, wonderful tools, but you need to understand that they are a baseline. They are not going to find every single vulnerability in your software. They're not going to exercise every workflow that your software may have. And they likely will not understand all the business logic in your software. It's still a necessary exercise to run scans against your software and find the low-hanging fruit, find the obvious things. If you have cross-site scripting vulnerabilities in your software, it will find most of them. Will it find all of them? Not necessarily. And if you have different technologies that you use, let's say you use Java, you use C, you use Golang, there's going to be different tools that are going to be better at evaluating each of those different languages or different technologies that you may use in your software. So there's not necessarily going to be one tool that's going to be your safe all for doing this either. But I just want to emphasize here, the security scanning is really a security baseline. It's also vulnerability focused. So it's typically not exploiting anything. It's typically pointing out areas where you might have a concern, potential weaknesses in the software that you have to evaluate and determine, can it actually be exploited? Tools here in this category are things like static application security testing tools, SAS tools, or source code analysis tools. Other ones are dynamic application security testing, DAS tools. Interactive application security testing, the IS tools, this is kind of a new one. They're kind of the new kid on the block. These are interesting. They take a little bit of a combination of the SAS and the DAS approach. Typically, they're running as an agent within the environment. They may do bytecode analysis or a bit of source code analysis as well. But still, this is really your part of the security baseline. This is it's a different angle of identifying vulnerabilities, but it's really not getting any deeper into the diagram here of penetration testing. Software composition analysis. This is looking at the components of your architecture. This is looking at third-party components, open source, any CVs associated with them. Container scanning. So as a lot of us are working on, cloud native and containers and Kubernetes and Docker. There's a whole new set of security considerations with that, and there's a whole new set of tools that will help you scan those environments, scan your clusters, and identify security risks associated with containers and container technology in general. Pipeline automation is really key for this whole top security scanning baseline. If you can automate these scans in your pipeline, that's going to help get you the results faster, and it's going to help ensure that you're covering that full breadth of the baseline, all of your software. But it doesn't, again, it doesn't get you any deeper in this diagram here. It doesn't get you to penetration testing. All it does is it gets the results quicker to the developers or the testers so they can review those results from the security scanning. So let's talk a little bit more about penetration testing. This is really more about deep and manual evaluation of the software. This is more of an art than a science. This is not just running a bunch of tools and looking at what the output is. This is actually exercising the business logic, exercising the workflows to see what can go wrong when you do something malicious or do something unexpected. This is exploit focused, so it's not vulnerability focused. This is more about, can I actually exploit those vulnerabilities that the security scanners say may or may not be there, or that some threat feed identifies as potentially being a security issue with my software. This is more about the proof. Can you really pull off an exploit, and what happens when you do? It uses things like threat modeling as to inform it. So again, if you have a blueprint of the architecture and you perform threat modeling on that architecture, that should be input to your pen test. That should identify to you the risks and the threats associated with your software. You should use that to figure out where to focus your penetration testing efforts. It uses entire penetration testing distros like Kali Linux. And so Kali Linux is not just one or two or three or four SAS and DAS tools. It's hundreds of different tools fit for specific purposes to be able to exploit a system or a piece of software. It will use things like exploit.db, so a whole database filled of published exploits that are out there. You can download them and try to run them against your system and see what happens. And things like Metasploit framework. So if an exploit doesn't exist for what you're trying to test with penetration testing, Metasploit provides you with a framework where you can craft your own exploits. So this is really more about ethical hacking. And ethical hacking is really more about, there's technique than specific tools. There are different phases here of ethical hacking. There's not one way to do this. It's more of that manual evaluation, which is going to change based on what you learn from the software, what you learn from the architecture, and what you learn from the threat model. And as you start to do that evaluation of it, it's also important to point out if you're hiring out penetration testing, which many organizations do, there can often be different tiers or different levels of penetration testing that you might contract out to a third-party vendor that specializes in penetration testing. Typically, what I see is that a tier one might be just really as simple as automated scanning tools. It typically looks like they're doing the security scanning. It's basically outsourcing the security scanning on the top here, and maybe they're doing a little additional evaluation, but it's not really much more than that. A tier two might be more of a manual exploitation of some low-hanging fruit. Again, they're running the tools and maybe evaluating some of the criticals that show up and see if they're actually real, true positive vulnerabilities, or if they're non-issues or false positives. Then you get into the deeper targeted attack scenarios. Obviously, you get more of the expensive range here of penetration testing and the more lengthy range. And then you get into more of the advanced attack scenarios. So I just want to press upon you that not all penetration testing engagements are the same. and there may be different levels of them. And you kind of have to, if you're going to hire out to a third-party contractor, you might want to learn exactly a little bit more about exactly what they plan to do. What is their process? How do they go about performing penetration testing? How deep are they going to go? Are they going to just run some scans and look at a couple of the results? Or is this going to be a longer term engagement where they're going to do some more advanced scenarios where they're going to really dig in and try to, force some business logic and exercise, some workflows that normally the tools will be, completely blind of. So for completeness here, let's just talk a little bit about red teaming. Red teaming is really an emulation of real world attack scenario. Red teaming is not about finding and identifying every vulnerability in your system or in your software so you can fix it. It's really about testing the incident response team. So we talked about FIRST and PCERT, and we talked about that framework for setting up a good PCERT team and a good incident response process. That's your blue team, right? So your red team should be basically challenging your blue team here to see, okay, can we, if I go and I do a real world attack scenario against your software, your system, is your blue team, is your PCERT team for incident response prepared to defend against that attack? All right, so moving on to the next stage. So now assuming, we've got the industry standards, we got the guidance, we got the frameworks, we're embedding security practices within the SDLC. We're doing some more of the advanced stuff now with penetration testing. Now it comes to, all right, how do we track all this? How do we make sure it's happening across the board, across the large research and development organization? So one of the things we did, actually SAS, was we created a ticketing system. And I want to just impress upon you that you need a lot of project management help for this. We like to use Jira. Jira is a very good tool for organizing your tickets. And it's a good way to keep track of, all of the different activities that are happening, especially around the scanning, making sure the scans happen, that the results are reviewed and all the issues are resolved, tracking threat models, tracking any security defects that you want to ensure are resolved in a timely manner. Having a system like this with a main story and a number of subtasks can be very helpful for keeping that organized and tracking that. What could happen though over time that I've observed is you can end up with a very large system of tickets, right? Flooding through and trying to keep track of over time. So obviously the next thing you might think of here is, all right, well, we want to reduce as much of the manual process of that ticketing system as possible. So how do we do that? And to do that, it's really to figure out how do we automate that whole system? How do we automate the collection and the validation that all of those practices are happening within the secure software development lifecycle? And this is really more about generating and collecting security artifacts within your build system. So if your build system has the scans built into it, generate the validation and the checks within the build system. As things flow through, are we doing our SAS scan? Has the issues been resolved? Is it highlighting any criticals, highs, mediums, or whatever your policy is? And make sure that those things are flagged within the build system to ensure as things flow through the system, the scans are happening, the issues are being resolved, and attention is being put on that stuff by the developers. Past the tracking and the automation of the build system is really about more maturing and optimizing those security practices to go deeper and making sure you're building a fully complete secure system for your customers. And this is really more focused on doing things like security architecture review, providing secure coding guidelines for your developers, and doing maybe internal penetration testing. So I know a lot of organizations hire out for a third party for penetration testing, and it's often the case, that that's actually a contractual obligation with your own customers, that there is some third party validation. But there's really no reason why you can't do or augment that with your own internal penetration testing. So don't just have the testers running automated scanning tools. Train the testers on ethical hacking. Get the testers exercising some of those paths that their third-party vendor might exercise. I think you'll actually find that your internal testers probably know the software much better than any third party you're going to hire to do a penetration testing. So you might actually get much better results from your internal pen testers, than a third-party vendor that you hire. Focus on root cause analysis. So one thing that's been very helpful is identify the top 5 issues that affect your software. Why is this important? Because actually, if you start to do trend analysis, and I go back to using CWE again, understanding CWE, and then as the issues are identified, from whatever angle that they come in from, if you're categorizing those by CWE, by the weakness type, that's going to help you build up metrics that you can then later on use to figure out, okay, what are the top 5 issues that plague my software, that plague my products, that my research and development organization is producing. Once you understand that, then you can focus in on eliminating those top 5 issues holistically across the organization. That can be very powerful and a lot more focused than trying to, just fix every single CWE that comes in. Because there are hundreds of different weakness types that could affect your software. There might be some that never come in at all. So I press upon you to try to focus, use the metrics to identify some of the top issues that affect your software, and try to find out why. And I think it's going to help you eliminate large numbers of problems within the software by focusing on some of those key areas. And then again, use the automation to go faster. I think a lot of vendors across the industry are focusing on CI/CD. I think CI/CD is actually a great thing for security. Why? Because the software is going out faster. So can the fixes. The fixes can go out faster as well. Then shorter remediation timelines should go right along with shorter delivery timelines. So it really becomes that continuous cycle of identifying it in the shorter time frames, fixing those issues within the shorter time frames, and releasing patches faster to your customers. Obviously, as technology changes constantly, right? We're cloud. There's a big shift to cloud right now. Cloud native, containers, Kubernetes, a whole new ballgame. New technologies, there's new attack patterns, there's new risks and new countermeasures associated with those technologies. So you have to continue to expand your scope by understanding what these new technologies are, and how to get out in front of them. I think the most powerful thing really though is to build security culture. So again, this kind of goes back to the security champions and embracing them and building them up. You can create policies, you can create standards in your organization to require people to do security, but none of that is as powerful as security culture. It really has to be ingrained into the people. They have to care about security. They have to take it upon them that it's their responsibility, that security is being cared for, and that they are embedding it within their teams to really make large strides in progress on security within the organization. And there are different things that you can do that have been very helpful and beneficial to me, such as running security open forums. So these can just be simple things as discussions with your security champions. You could do presentations, or it could just be an open discussion to just talk about their concerns, or just help train them and educate them about security. Lightning talks. These have been widely popular for me. These, the short 5-minute talks. You give your security champions or people around your organization a chance to just talk about security. Just keep that conversation going and keep it informative and interesting. I think one of the benefits about 5-minute lightning talks is, they're quick and they're packed with a lot of interesting content. So it keeps people's attention. Demos. The more demos you can do, the more real you can make it for people. Just explaining to developers or management or leadership, yes, we have security problems, or yes, we have this cross-site scripting problem. Not everybody else has the same vocabulary, the same security vocabulary as you might have. Providing a demo and showing them in real time what does an exploit look like and what are the results of that makes it that much more real to them, especially the people who are not familiar with security. Panel discussions. Again, this is not just another way to get some people together that have either a background in security, or maybe they don't have a background in security. Maybe they just want to learn more from some people who do have a background in security. Just keeps that conversation going. Cybersecurity Month. So we're wrapping up. Tomorrow, I guess, is the last official day of October is Cybersecurity Month. At SAS, we do actually an amazing job around planning activities and events for Cybersecurity Month. This should really, every organization should take this October as an opportunity to really drive awareness and celebrate, cybersecurity at your organization. Make it fun, get people involved, give them different ways to participate. All of that is really about building strong security champions. You don't want to build best effort security champions. You don't want to build, people are just kind of checking off a box. You want to build people who feel empowered, and that you're helping to go back to their teams and really drive security into their team to make sure it's always kept at the forefront of what they're doing as they're building software. CTFs can be another great activity to get a variety of people involved who are interested in security. OWASP has a great project called Juice Shop. We actually ran that, and it was actually widely popular. We had a lot of participation in Juice Shop. Another option is we had a old version of our software from 15 years ago that we didn't apply any of the patches on, and we just set that up internally and said, hey, just go try to capture our flags in there. Let's see what you can find. Just another interesting way to get people engaged and actually with security testing and trying to use some of those ethical hacking skills or learn a little bit about ethical hacking. Bug bounties. This is a game changer for me. Bug bounties are, I always kind of looked at bug bounties like, it's an interesting concept. Wasn't really sure how it would play out. We just did our first bug bounty, and I got to tell you, the results were actually amazing. I have a little bit of a snippet here. I have redacted our engineers, our developers' names here from the list, and some other, any SAS specific information from this dashboard. But this is basically this is a mock-up of what our internal dashboard looks like. So Michael Myers there, again, that we're just talking about horror films here for the bug hunters. These aren't real people that work at SAS. Done an amazing job. This has been a way to basically we set up an internal program here to get people involved with doing ethical hacking of our software and identify security issues. It was really pretty simple. Basically, we just did this whole thing through Confluence, and you can see some of the totals here are actually pretty impressive. Just in a month long of running an internal bug bounty. So I had no third-party help here. Didn't have an outside company come in and run this for us or anything. Basically, just set up a very simple, poor man's lightweight bug bounty system. It's a Confluence page with some basic rules of, okay, here are the target systems that you're allowed to attack for the month of Cybersecurity Month. Here's how you can submit them. Submission is very simple. Just email my team. My team has a group email. Send us the submission of a JIRA ticket that you've opened with the issue in it. We'll do the evaluation. We'll score it. And the point system is just based, again, on CVSS. So again, the industry standard for scoring the vulnerability. So you get points based on the CVSS score. You can see here Michael Myers is he's got one submitted, which we haven't evaluated yet. So you can see in the status key here, we transition through different phases. Initially comes in and submitted. Then it goes, once my team starts looking at it, it turns into evaluating. So you can see Hannibal Lecter here, he's got one submitted and then he's got one in evaluating. If we determine it's a non-issue, or maybe it's a duplicate of another issue, then we'll reject it. We'll put that information into the JIRA ticket. So you can see Hannibal Lecter, he got one of his was rejected. If it's a real issue, if it's a brand new issue we haven't seen before, then we mark it as accepted. We score the defect, we score the JIRA ticket, and we give you points for the CVSS score with your ticket. If you do a demo, that's awesome. We'll give you double points on the demo. So you can see there, Michael Myers has a bunch of all of his that he's actually submitted. He's gotten the CVSS score, plus he's gotten the demo points. So he's doubled his points here. and he's broken over 100 here. As of last night, that's his points. Actually, he's got some new submissions today that I haven't been able to refresh the slide. But this is kind of just a simple way to use CVSS to create a point system and incentivize people to do demos, because the demos are great. The demos make it real again. The demos can then be used for educational purposes. We can, as we're patching these issues, the demo will remind us what issues did we have in the software, and what did we find, what did we fix, and how do we prevent that going forward. The demos also help with the evaluation when we're actually trying to do the scoring of it to figure out how severe this issue actually is. So that's a great way to collect all that information. We have also doc issues are important too. So this is just a snippet of the top of my leaderboard, but there's lots more participations in this competition that are much lower below on the real Confluence page. But we give points for doc too. So doc, it's important to make sure your security doc is up to date and it accurately reflects the status of your software, of your products, any certifications that you have, any the security controls, all that's important as well. So we do have doc submissions, and we give 1 point for that as well, as people find doc submissions or make improvements to the doc. I think it's important to emphasize that should be counted too. Another thing that we found that was interesting out of this whole exercise was we opened this up to the entire company. So this wasn't just research and development. So while research and development is the primary group that's creating our products and testing them and doing the coding, by opening it up to the whole company, we actually found that we had bug hunters in other divisions who were just interested to participate. They made submissions. They wanted to learn about ethical hacking. They seemed to have some skills that we didn't even know they had. We have some of these bug hunters here. I think Hannibal Lecter is from the IT division, so he's not even in research and development. I think Chucky is actually in the legal division. There's another bug hunter who's in the tech support division. So another way to kind of get broader coverage, more eyeballs on the software, and additional testing out of other parts of the organization that aren't even normally focused on doing that kind of exercise on your software. So definitely, to me, a game changer. Looking forward to doing a lot more of these. I'm completely buying into the bug bounty system now. I've always been a little skeptical of it when I've seen presentations on it and seen other people doing it. But I mean, this is a lightweight system that you can really just do internally. I have no outside. I'm not paying anybody on the outside to do this for me or to manage the system for me. Basically, me and my team are handling this completely ourselves. So definitely an interesting thing that I'd recommend trying out for yourselves and seeing how that works. So let's kind of wrap it up here. I think I'm on my last slide. So lessons learned along the way. So it's been an interesting 5-year journey, kind of building out the program, seeing it mature, building out different capabilities. So I'm just going to kind of finish it up with some lesson learned. So start tracking security defects. Obviously, that's like the beginning starting phase, right? Being able to label them, categorize them by CWE, all that's going to be important as you try to build out metrics and understand, where are your problems and what are the things that need to be fixed in your software. You're going to need project management support for that, for sure. There's a lot of this. That's heavy security tracking. If you're a security expert, you need to partner with project management because it's a different skill set. If you have all your security people doing project management work, you maybe don't have your security people using their security skills. So partner with project management, let them help you. Project managers are good at tracking things. Let them help you with this. Score your defects honestly. Okay, so if you're scoring everything as a critical, then nothing's a critical, right? I really recommend use CVSS that's used across the industry, that's used in the NVD, it's used for CVs. There are buttons on that calculator and the buttons tell you what the buttons mean. Make sure you're doing an honest assessment when you're scoring things. if you have somebody scoring things and marking them high just so they get extra attention, that's not really helpful. You're actually making the problem worse for your organization if you do that. Use industry accepted maturity model to help guide you. So again, OSM, it's used across the industry. I know our customers use it. I know my peer organizations use it. There's a lot of good guidance in there. I'm not saying you have to do every single thing in there to a T to what they say, but at least understand what it says in there and figure out how to apply those things correctly to your organization and your SDLC. Industry trends and patterns. Identify trends and patterns from your customer reporting trucks. I should also put there, even from your internal scans and your internal pen testing as well. Having a top 5 CWEs is very helpful, especially if you're having conversations with management and leadership. Just saying we have a bunch of security problems is not going to really be clear to executives, right? You want to be able to describe, yes, we have security problems, and here are the type of security problems there are, and this is why they're a problem, and how to fix those problems. If you can break that down to a top 5, that's extremely helpful. Prioritize, obviously you can't fix everything at once, especially if you're just starting out, if you're just getting some tools going, or you're just getting a PSERT process going. Prioritization is going to be key. You could start with a mountain of information, and you really need, again, you need project management help to support you on tracking that and keeping the prioritization right while you're focusing on the security aspects of it. Again, utilize industry standards, frameworks, and best practices. So NIST, OWASP, FIRST, great resources. They're publicly available. They're free. ISO is a good resource too. Well, ISO, you have to pay for those documents. Those are not free. So not saying there's anything wrong with them. I'm just saying NIST, OWASP, and FIRST, that's just free. You can just download that and look at that today. Let security tools do some of the heavy lifting. So I mentioned lots of different tools out there. Again, it's an automated baseline. It's necessary. It's going to find the low-hanging fruit. It's going to find a lot of things that you need to look into, and you definitely want to put that within your pipeline. Try to automate that within your build system. Threat modeling, very powerful tool as well to focus on during the development lifecycle, early on when you're doing design and when you have an architecture. Very good. The STRIDE method is probably one of the most well-known methods used for threat modeling. Definitely very, very helpful for identifying risks and weaknesses within the software. And continuous professional education. This is extremely important, especially as you're moving to new technologies like cloud, containers, Kubernetes, Docker, all these things. There's a different set of risks and countermeasures associated with those technologies. Different set of patterns as well. So you have to continually learn about the new technologies so you can keep up with the threats associated with it. And regularly update your leadership with status. If your leaders are not aware of what's going on or how things are progressing, it's not going to help you make a lot of great progress. And I would just say communication and presentation skills are definitely critical in trying to get your message across or your points across to an audience that may or may not have as deep of a security background, probably does not have a deep a security background as you, and maybe at a different level of how much understanding they have of security. So definitely important to be able to do those demos and present the material to them in a way that they can consume and understand what's going on. All right, so that was it for my deck. I think we got a couple minutes left here for questions. So yeah, happy to answer any questions that might have popped up. So I see one here. It says, with multiple products, how do you get the security issues into their backlog? Or do you have product security group JIRA projects that everyone goes to add it in their backlogs? So yeah, so every team has their own central JIRA projects. There's a JIRA instance, and then each team has its own JIRA project. So when an issue is identified in a certain team, in a certain component, a certain area of the software, the defect it's just another bug. The bug gets opened up in their JIRA project. It gets assigned to either their security champion, or their security champion will help identify the best engineer or the best developer who can evaluate that security issue. So it all gets entered into their system. It gets tagged security, and we have the scoring built right into the Jira system. So once we score it, that score is associated directly with the bug. They know what the score is, they know the severity of it, and they know what the goal date is. So we have internal remediation standards where we say, okay, this is a certain severity issue. It has to be fixed within a certain time frame. So that having that all in the ticket then helps enable project management to ensure that it gets into their sprints and their cycle, and they're getting that resolved in a timely manner. So great question. Hope I answered it fully there. Any other questions or?
All right. I see a few applause for you and some thank yous and some great presentation. So yes, I definitely would agree with that. Great presentation.
All right, thank you. Well, I'm happy to be here. Glad to be a part of the Triangle InfoSeCon, and
Definitely.
thanks, folks.